Hey guys, and welcome back to a new video. In this video I will cover everything you need to know about Retrofit. So we will make a very basic app here that fetches data from an example API that you can also use, of course. So when I relaunch the app here, then you will see there is a progress bar, and when it loads it just shows all the to-do entries or whatever that is in RecyclerView. And yeah, that is basically fetched from the network. I will really do everything here in this video, so I will also do the layout part. So really the app from scratch. If you don't want to see the layout part, then you can find jump marks on this video, so you can just skip to the coding part and get the layout from my GitHub repository in this video's description. So the only real prerequisite you need here for this tutorial are the dependencies. So here I'm just in an empty Android Studio project, and here in the build.gradle file you can see I already pasted the retrofit dependencies and the coroutine dependencies and the lifecycle scopes for coroutines, because we will use coroutines here in combination with retrofit to make our requests and get the responses. So you can just go to my GitHub repository, link in this video's description, and copy these dependencies over. And also don't forget to enable view binding here, because we will use view binding here, but the rest will be made from scratch. So we will actually get our data here from this website, jsonplaceholder.typicode.com, and you can see that has a /todos, and that is just an example API just to experiment with that. You can see that is a JSON response we get here with ready-made example to-do items. So every to-do item has a user ID, which we won't need here. It has a real ID that is unique here. It has a title, which we will show in our RecyclerView, and it has a Boolean whether this item is completed or not. So just very quick, what is Retrofit? Retrofit is just, I think, the most widespread library for Android to make HTTP requests to get this kind of data. So if you have some kind of JSON data and you want to get that into your app, then Retrofit is the library to use for that, because it just works very intuitively and easy. And also this tutorial, as I said, I will do this app from scratch, but I will really focus on this Retrofit part. So I won't go very deep here into RecyclerViews and all that stuff, but I will still cover it in this course. So let's get back to Android Studio, and we want to start to make our layout. So we switch to our REST folder, layout, activity main XML. So everything will happen here in this main activity, where we just have an hello world text view, which we don't need. We can click this and remove it. And then we want to switch to the code tab. I will open this tag here, and in here we will have two views. On the one hand, we will have our recycler view, of course, match parent. This will just fill our whole screen. We can give it an ID of RV to-dos, because it's a recycler view that displays to-dos. And we can close this tag, and we will have a progress bar that will just display when the request is made and will be made invisible when we get the results. This will have wrap content and wrap content. Give it an ID of progress bar. And that is actually it. Now we need to set the constraints for these two views. Let's go back to the design tab. Click on the recycler view and constrain it horizontally and vertically in parent. And let's do the same for our progress bar, horizontally and vertically in parent. And we should, of course, set the visibility of this progress bar to gone by default. So back in our code tab, we set the visibility to gone. And that's it for our main activity. We also need another layout, which is the layout for our to-do items. So there we just have a text view in a checkbox. So let's go to our layout folder, new layout resource file, and I'll call it item to do. press enter. We will directly switch to the code tab. And here we will first of all have a text view that displays the to-do's title. Layout width, let's set it to wrap content for now. We will change this later. Height as well. Give it an ID of TV title. I will give it a little bit of margin start. Let's say 16 dp. I will set the text size to 20 sp. And I will set tools : here we need to press Alt plus Enter to create this namespace declaration. We will set the text of that to placeholder, but because we prepended tools here, this will only be applied to the layout editor and not to the text view in our app. Then we can close this tag off. Then we also want to create a checkbox, whether this to-do item is done or not. Wrap content, give it an ID of CB done for checkbox done. And that is actually already it for that checkbox. Now we only need to set the constraints for those two views. Let's switch back to the design tab. Actually, no, let's switch back to the code tab. We also want to set the height of our constraint layout to 75, not 85, 75 dp. It's always hard to see my keyboard here because of my mic, but let's now switch to the design tab. You can see now we have an item with a height of 75 dp, and we want to take our placeholder, constrain the left to the parent left. Then we constrain it vertically in parent. Then we take our checkbox, constrain the right to the parent right, and also vertically in parent. Then we want to take our placeholder again, constrain the right to this checkbox's left. We don't want to have this centered. Instead, we want to fill the whole width, so basically from here to here. So what we need to do is we need to set the layout width of that text view to 0 dp. So back in our code tab, change this to 0 dp, and it removed the margin. Let's reset that, margin start 16 dp. And then, yes, now it looks exactly as I want it. Okay, let's now get to the retrofit part, which is actually more exciting, which is why you watched this video. First of all, we need internet permission for retrofit. So let's switch to our manifests folder and make sure that we don't forget this. This is a very common cause of crashes here. Users permission and internet. Whoops, I want it like this. And that's already it for the manifest. Now, how do we actually tell Retrofit how we want to access our API? So our API is in the end just what I showed you here in Chrome, which is a remote service that provides some data for us, or that we can also use to post data. Well, I will only show you how to get data, but posting data or updating data is basically the same with Retrofit. For that, we need to define an interface. So we go back to Android Studio and create a new class, Kotlin class of file, and it's actually not a class, but an interface here. And we will call this to-do API. So in this interface, we now define all the functions we need to access our API. So in our case, that is just a single function to just get all these to-do items. But in a real project, you usually have much more of these functions. You might have a function to post a new to-do, to update a to-do, or to delete a to-do that is remotely saved, or whatever. But just for demonstration, I will show you how we can retrieve all of those to-dos from that API. So we define a function here. We call that get to-dos, and what will that return? With Retrofit, we want to return a response. You can see that is a response that takes a generic argument. So it's always a response of a specific type. And well, of what type is our response that we get here? If we now take a look back in Chrome, then, well, we get a JSON response here. So of course, JSON is just a way of communicating. that everybody, or rather every language, can potentially understand or parse to something the language really understands. So what we essentially need is a network model class. So we need a class that represents such a to-do item here. So a data class that has a user ID, a normal ID, a title, and a completed Boolean. And you, of course, could now just create a data class and give it exactly these attributes. That would work here. Those are not many attributes, but often in practice you have much more of these attributes, and then it would be very tedious to create these data classes by hand. To solve this problem in an easier way and more comfortable way, we can simply copy this JSON response of a single to-do item and then use a fancy plugin here in Android Studio, which is called here Kotlin data class file from JSON. So in case you don't have that plugin, you can press Ctrl Alt and S to open your settings, and then we want to scroll down to plugins. You want to go to Marketplace and search for JSON to Kotlin class. So that is the plugin you want to install here. I already have it installed, but when you have that and restart Android Studio probably, then this option will occur for you. You click on that, and here you can simply paste that JSON response that you get from your API, and this plugin will now generate the data class for you. So you can see down here, we need to give this data class that will be generated a name, which I will just give to do, because that is a to-do item. Then we click on generate, and you can see here a new class popped up. If we open that, here's our data class to do, completed Boolean, ID, title, and user ID, and also the types are correct. So now we have a Kotlin class in which we can parse the JSON response we get from our API. So you might think now, okay, that will be a response of type to do, but that's not correct because we get multiple to-dos. So what we essentially want to have, we have a list of to-dos. You can also see that here in Chrome, though those square brackets always mark that we have a list of something in JSON. And these curly brackets just make this a specific object. So in our case, a to-do item. Okay, but now that is just a standalone interface, and it doesn't have much to do with Retrofit. We somehow need to tell Retrofit how we want to retrieve those to-dos here. And when we're talking about HTTP requests, there are 4 main types of requests. On the one hand, GET requests, POST requests, PUT requests, and DELETE requests. GET requests, well, are just used to retrieve some data, to get some data. That is what we will use here. POST requests are used if you want to post some data from your device to the remote server. PUT requests are used to update data on the server, and DELETE requests, well, to delete data. But since we want to retrieve data here, we will use a GET request, and then we need to annotate that with @get. And here in the parentheses, we need to specify a string. So the string that we need to put in these parentheses here can be found if we take a look at our API. That is whatever comes after our base URL. So the base URL is everything until .com. So this part here is the base URL, and this is the specific URL of that whole URL we want to actually get something from. So we will specify the base URL later, but we are interested in this /todos now. So we go back and write /todos. And now with this function, it's the case that we don't have any query parameters. So we don't pass any parameters to this function. Usually that's the case, or very often, for example, if an API takes an API key, so you somehow need to authorize that you are allowed to access that API, then you need to pass that API key to each request. So then you would need to write @query here to make that a query parameter. Here you specify the name of the query parameter that the API accepts. So maybe API key or just key. That is very individual from API to API, and you will have to read the API documentation to find that out. And then you can give this a name and a type. So that is how you can essentially attach query parameters to your requests. That is not what we want to do here. We don't need an API key or any other parameter, but that is still something of Retrofit. You need to know how that works. So I still want to show you that. I also want to show you another functionality of Retrofit, which we don't need here, but which is important to know. And that is if you actually want to post some JSON data to a server. So let's say we have a post request here, function post to do or create to do. So you create a to do in your app and you want to post that to the server. Then this will also answer with a response. Here, probably not with a list of to-dos. Let's say that is a create to-do response. We don't have that class now, but just that this looks a little more realistic. And then this would be a post request. So you can see for each type of request, we have an annotation here. And let's say that is create to-do. And now, how would you attach the to-do that you have to this function so it actually gets posted to the server? This time you can't do that as a query parameter. Query parameters are just these parameters that you have in the URL. If you want to attach JSON, you need to make that a body parameter. So you want to attach a JSON body. And here you would pass the to-do then. And this would automatically get parsed to JSON if you have this body annotation. And then the server will just worry about this to-do that you post to it. So just that you have seen this, because that is a crucial part of Retrofit that you need often, but it's not always that easy to show that with an example API. You would need a real API for that. And I actually did that in my news app playlist. So make sure to check out that if you want to see how you can apply that in a real project. Let's get back to our app here actually. This is almost everything for our to-do API interface. One more thing that's missing is, well, we want to execute our request in a coroutine. So network requests should always happen asynchronously, never on the main thread. So what we want to do here is we want to prepend the suspend keyword, and that will automatically execute that in a coroutine. Okay, now we have that interface, but we also somehow want to create an instance of that interface. And for that, we need to create our custom Retrofit object that will create this real API for us, so we can use this function to make actual requests. For that, we will go to our root package, create a new Kotlin follow class, and call that Retrofit instance. Select object here because that's a singleton. And in here we will create our API. If you use dependency injection with Dagger Hilt or so, then you don't need this. Then you instead create this API interface in your specific module and provide it. But we don't have that here. So we will have a val API here, which is of type to-do API. And we initialize this by lazy. That just means it won't be initialized right away. Instead, it will be initialized when we first access this API. So in here, we can use retrofit.builder and then construct our API. So you can see we have a bunch of functions we could call here. On the one hand, we need to pass our base URL, which I explained before. That is just https :// JSON_placeholder.tpcode.com. So that is everything which does not belong to this part after the base URL basically. So that is just the URL that we want to access to get all to-dos. And that is the URL that we always access with our requests. So I hope that gets clear. Then we can also add a converter factory that will be a JSON converter factory.create. What does that mean? Well, we somehow need to, our Retrofit somehow needs to know how it should take the JSON data it gets and how it should parse that to these data classes that we created here. And for that we will use JSON, which is just a converter for JSON. We could optionally also add a converter factory here that will be useful if you want to parse the response to something. For example, if you want to get that as Rx Java stream, but we also don't have that here. So we can leave that empty. So then we can just call build to build our API, or rather that retrofit instance. That's not the API yet. For that we need to call create and specify the class of our API. And then the errors are gone, and we can use this instance here to make our API calls. And now that we have our API to make our requests, to fill our RecyclerView, we of course need to create the RecyclerView adapter next. So new Kotlin file class, to do adapter, select class, which will inherit from RecyclerView.adapter. And here we create an inner class for the view holder, like this. And then we will have that here in a class to do view holder. Since we use view binding, we need to pass the binding here instead of view. So binding of type item to do binding. If you don't have that, make sure to have this view binding true included here in your build.gradle Gradle file. Then we let that inherit from view holder. Here we need to pass a view, which is just binding that root. Then I will just use a basic list differ here. So in case you don't know what divutil is, that's just a tool basically that makes it very efficient to update recycler views. I won't go very deep into this here. You can watch my project playlists where I explain this in more detail. So for that we just need a div callback, which is of type object, divutil.item callback. Here we always compare to do items. So we just need to define how we want to compare our items, how divutil will decide if it should update an item or not. And here we'll have two functions, our items the same and our contents the same, which we will override. For our items the same, we can just return old item.id is equal to new item.id. And for our contents the same, we return old item is equal to new item. Then we can create a private val for our actual list differ. So differ is equal to an async list differ. So that updating process will happen behind the scenes, basically on a background thread. We need to pass our adapter, which is just this, and our differ callback. And then we will have a variable for our to-dos list. So that is a list of to-do. We're going to override the getter for that, which is differ.currentList, and the setter, which is, or rather in which we want to submit a new list, so differ submit list value. And I know I went quicker through this because, as I said, the focus is not on divutil in this video, it is on retrofit. So then let's just override the three functions we need for each recycler view. On the one hand, get item count, which is the easiest function. That will just return the list of our, the size of our list. Then we have on create view holder. Here we need to return an instance of our view holder. To do view holder, we need to pass a binding. So item to do binding that inflate. For that we need to pass a layout inflator that from. We can get the context from our parent. Then we need to pass the parent itself, and we don't want to attach this to the root layout. And finally for onBind view holder, in which we just set the data to our views in our recycler view. We will use our view holder dot, actually I think, yes, this binding must be a val so we can access it. So now we can call holder.binding.apply, get the current to do item by writing val to do is equal to our to do's list at the index of position, and then we set tv title.text to do dot title and CB done, so our checkbox that is checked to do dot completed. Now that's it for our RecyclerView adapter, and the rest will basically happen on our main activity. If you use MVVM architecture, which I suggest you to do in a real app, then you would make the retrofit call in the repository and then call that from the view model, but that would be too much here. So I will just do it from here. On the one hand, we of course again need an instance to our binding instance. Private init var binding is activity main binding this time. Initialize this here. Dot inflate and pass our layout inflator. And then we swap this out with binding dot root. Like this. Then we want to create an instance of our RecyclerView adapter. To do adapter of type to do adapter, nothing special. We create a private function to initialize that RecyclerView and just set it up. Set up RecyclerView. Set it equal to binding dot rv2dos dot apply. First, we set the to-do adapter to a new to-do adapter. Then we set the adapter of our RecyclerView to this to-do adapter, not this, to-do adapter. Then we set the layout manager of this RecyclerView just to a linear layout manager and pass this at main activity, because just this would refer to this RecyclerView here, so this apply block. Then we can simply call that function here and on create, and now finally make our API request. So as I said, we want to execute that API request on a background thread. So we want to launch a coroutine here, lifecycle scope dot launch when created, which is just a coroutine scope that is lifecycle aware. So this coroutine will be cancelled when the app goes in the background. And in here, we first now want to set our progress bar visibility to true, because now we start to make our API request. And as long as we make that, our progress bar should be visible. And then we can get our response in a try and catch block. So if we use retrofit with coroutines, then we can catch errors by simply doing that request in a try and catch block. So here we simply use our retrofit instance, our Singleton, our API, and here when we first access it, it will be initialized, and get to-dos. And we want to catch two types of exceptions here. On the one hand, an IO exception, and on the other hand, an HTTP exception. So what is the difference between these two exceptions? IO exception is, well, most likely that you don't have internet connection, but it can be multiple, it can have multiple reasons. So you definitely need an additional internet check here in a real app, but just that you know that there are two types of exceptions. It could also be that the output stream is closed or whatever. So I just want to have a log statement here, an error log. We need to create a tag here. Console tag is the main activity. And here we just write IO exception. You might not have internet connection. We can copy this, paste it here, and replace this with HTTP exception, which usually happens if you get an unexpected response that doesn't start with a 2. So if you have HTTP responses, those are just 3-digit code. And if this 3-digit code does not start with a 2, then this HTTP exception will be thrown. So that usually means unexpected response. And in both these cases, we want to return out of launch when created. So if this code continues until here, we know for sure that we got a response back. But that does not yet mean that the response was successful. We still need to check that. So if the response is successful, so that just means that it returned the HTTP OK status code. And if the response.body, you can see that now returns a list of to-do items. If that is not equal to null, then we know that we really got to-dos. And then we can use our to-do adapter .todos and assign our response.body to this. So we now set our to-dos list to our adapter. And here we need to assert that it's not equal to null, but at this point it will never be null here in our case. And else we want to, oops, not paste that one. We're going to paste an error log again. That just says response not successful. And finally, call binding.progressBar and set the visibility to false again. Because either way, if it was successful or not, we want to hide the progress bar again. And by the way, we should also use this and put it here in the catch blocks, because if we return out of those, we also want to hide the progress bar before. And that is really it. I know this seems to be a lot to make a simple HTTP request, but usually you need to make multiple different HTTP requests, and it's actually very easy to add more now. It's just the initial setup that requires a little bit of work here. So if you have more types of requests, then you just go into your API interface and add more functions, and that's it. Then you can access those. But yeah, essentially as a quick little recap, you need an API interface to define how you want to access your API, in which ways here. And then you can use that API interface to simply create that API with a Retrofit builder. And then you can use that API, as you can see here, to execute the functions you defined in that interface. And that will make the actual request. So let's quickly launch our app and see if everything is working, but it should. It loads, and there are our entries, our to-dos. We could check those, but this doesn't do anything here. It's just important that these that are checked by default are also checked here. The titles all match, and yeah, just a bunch of to-do items here, and you have successfully made maybe your first HTTP request in Android. If you don't just want to make such a basic app that needs to make HTTP requests, then you can, on the one hand, watch my news app tutorial, as I said, where we'll just make a basic news app. But if you are looking to build your very own API so that you can decide which data is returned here, then check out my website where you'll find a Cato course. So Cato is essentially just a backend framework that is completely based on Kotlin and coroutines. And with that, I show you in this course how you can build your API, use Retrofit to retrieve that. So you will learn how to make a node app that just creates nodes, and those nodes will be synchronized with a remote server. So these will be saved online in your very own server. And yeah, if you just want to learn that is a paid course. That is a way you can support me and my work, but of course also to dive deeper into Android and backend development. So if you're interested, check out the first link in this video's description, which will lead you to my website, and there you will find my premium courses. With the code Philipp15, you will get 15% off, by the way, of all these courses. So that's it for self-promo. I wish you an awesome day. I hope you liked this video. If so, tell me that below in the comments, and see you in the next video. Bye bye.